invitation. We appreciate that, and Cammon hosting here. So my background is in microelectronic packaging, so I really work at how do we make things smaller. I worked at Harris prior to L3 Harris for about 28 years, I don't know, something like that. I actually worked in this building in 1993 for back in Harris Semiconductor days. So I've been in the area for a while. The company I'm affiliated with is in Orlando, but because my office is my computer and my phone, I generally work at home and travel for various reasons. So what I'm going to cover today is the two companies that I'm affiliated with, and then I will move in. So it's kind of a three-part presentation. So just to give you some background on what we do as far as the day job goes, and then I will talk about the International Microelectronics Assembly and Packaging Society, which I'm the Florida chapter president. And so that's a society that supports, if you've heard the CHIPS Act, which I'm sure you have, we as a society support that industry. And I'll talk a little bit about the society and kind of where it is working through in terms of workforce development and what's needed there. And then finally, it's kind of my passion, so if I could just do this full time, I would, but I'd talk about the K through 12 outreach stuff that I get involved in. So I'll first talk about Sciperio and Scrypt. So this is kind of a timeline. Sciperio was born as a technology company. It is still a technology company. I spend most of my time on that side of the business. And it was developed back in 1999, DARPA. If you're familiar with DARPA, the Defense Advanced Research Project Agency, they were interested in using printing technologies, graphical printing technologies and so forth for making electronics. When I was at Harris, we did a bit of that. I had a great interest in it, and so when 3D printing was really in its early days, my interest was how do we merge printed electronics with 3D printed stuff. I know Ken Brace, he's got his booth back there, so we've known each other a long time as well. So he's focused on the structural side of things. And so where we've been moving is really merging the electronics to it. So I actually met Ken Church, who first started this, and we had the shared vision of how to bring this all together. So you can see the timeline. And so Scrypt was born out of the technology developed out of DARPA. And so we have the two companies, and I'll do kind of a deeper dive in both of these as we go. And you follow the timeline. So we did launch a bioprinter to the International Space Station in 2019, I think. It was right before COVID just spun up, but so we spun up before that. And so we are currently building a 3D printed electronic system that's already done the flight testing, microgravity testing, and that's slated to launch next year. So Scrypt, they're located in Orlando. Sciperio, we basically take the whole bottom floor of the building. Half of it's Sciperio, half of it is Scrypt. Sciperio side, we do all the government contracting stuff. And then on the Scrypt side, basically it's the 3D printing technologies that were developed. And so from there, what we call direct digital manufacturing is basically where you have a digital file that has all the information in your product, and you basically hit print, and it doesn't care what you're printing. And that's really the end game with all of this. So if you have interest in like low to medium volume but high mix, which the DoD does, that's kind of one of the market areas that we really target. And so we talk about going from the digital to the physical, and then within all of that, you'll keep hearing about cybersecurity is very important here. So in the commercial world, your intellectual property is basically encapsulated in a digital file. In the DoD world, there's a lot of classified embedded information that happens as well. So we care about all of these things. So on the Scrypt side, we build systems. So we're an OEM. So if I wear my Scrypt hat, I'd be happy to sell you one of these systems. We are not cheap, and there's a reason for that. So basically what we have been doing is integrating different processes, as we talked about factoring a tool, also factoring a box, whether it's a Connex box, which is an expandable container, but be able to integrate a lot of processes and a lot of materials to enable you to build things. In fact, Cam had purchased a tabletop version of this one here. The largest system that we build is 8 foot by 10 foot by 12 foot. You can stand inside of it. And we have two systems, one that prints from ground up 3D structures and electronics. And then the other one, you can take very large round things and put it in there, rotate it, and actually print sensors onto that. So that's a capability that we've been continue to develop. So this is kind of from the electronics world, which is where I really live. How do we stitch together processes that enable you to make electronics and enable you to package things? So you can start thinking from a packaging perspective in non-traditional terms. Historic packaging is basically is flat. It's printed circuit boards, and you put printed circuit boards in a box, and off you go. Whether it's your phone or a payload, those are the traditional ways of making things. What we're looking at is how do you print the end product that has the embedded stuff in it, and that's the direction we go. So we have a lot of these systems. We sell internationally, but the DoD, particularly the Army, owns a number of these, and so I do a lot of contracting with the Army on a variety of topics. And so what you'll see is basically the ability to use multiple materials, because we become material agnostic. So you don't have to put proprietary materials in these systems. A lot of your high performance 3D printers, they have their own materials they sell you. Here, you just bring your materials and we'll print it, whether it's a liquid, slurry, or thermoplastic, doesn't matter. From there, we have a variety of different things that you see where we can print materials, and well, like in here, that's actually printing multiple material in the same system as you go. So, functionally gradient structures are very impossible. And why do you care about that? If you're bonding two dissimilar materials that expand at different rates, your failure mechanism is the interface. So if you start blending that interface, then you've got a capability that brings to bear that can bring forth a lot of reliability. Is this in prime time? Are we full production in parts yet? No, but we are getting very close on a number of things. And then, of course, we can print helmets for Army ads, so we have that capability. And so it's kind of a blending of whether structures or on the full right is actually electronics, and I'll talk more about that side of it. Chiplet integration, if you're familiar with semiconductors, they make wafers, they come up into chips, and now they have to package them. And so what we're doing is being able to package those in a different way, and then embedding them in structures. And that means whether we're, instead of wire bonding, we're actually printing to chips and things of that nature. And so that really gives you a capability. Here, this is a flat device, more traditional that you would see if you were to use a standard printed circuit board. So that the substrate itself was printed, the interconnect was also printed. So regular circuit boards is FR4 is a type of glass fiber type of board, and then they put copper on it, they etch it, and it becomes a subtractive. This is more additive from that perspective. Here, again, within the same system, you could touch a lot of different technologies. A lot of people are interested in peel and stick, flexible textiles. We printed antennas on fabrics and things of that nature, as well as moving into the bottom, which are fully printed. So everything you see in the bottom 3 devices are fully printed. So the structure's printed, the electronics is printed, the devices are pick and place into it, and like the cylindrical one, we stopped printing so you could actually see what's inside of it. Actually, when it's done, all you see is a cylinder. So again, so we call this 3D printed electronics. So that, and the other term for it is additive manufactured electronics. And so there's a lot of standards group that we're now developing new standards for this kind of technology, whether it's IPC or other standards-based. IEEE, I'm part of the working group there. So these are what I would call non-traditional. They're cylinders, but they could be any shape. We've done UAV, printed on UAV wings, so you can give me something, we can real-time scan it and print on it. The smallest thing that we've ever printed was we printed an antenna on the forehead of an ant. Not that you need it, but we have that capability. So, and then when he woke up, he was kind of, we have a video, I didn't bring that, but yes. So, but what you see is really kind of the merging of a lot of different materials, and so we work with a lot of material companies throughout, actually globally, but we're really focused on some U.S. source materials because some of the things that we're bringing back to the country, particularly what's been really focused on in the CHIPS Act. So, so we're very focused there. This is, so we have a contract with Space Force, so we're 3D printing, we're developing a 3D printing capability of printing CubeSats. This is a 6U CubeSat. If you're not familiar with CubeSats, a 1U is about a 4-inch cube, and a 6U, it's 8, so it's 2 by 4 is what it is, ends up being. And so everything you see here, except for the battery, was printed. So we printed the heaters to keep the batteries warm because it's cold up there, and so to monitor that, and so the battery housing actually 3D printed. So what you see here is more of a traditional way of doing it. So what we like to do is build it traditionally, and then use the new technology and make very similar, and then we can correlate the performance. But the goal is to take the individual boards and actually merge them into the sides of the satellite. So if you think about a very small satellite, it's very volumetrically challenged. So you want to basically put all the satellite functions in it and then add payloads and have more volume to add the payloads, and that's really the goal in all of that. And then it was mentioned that I worked in a container, and it was back here. That was for the Army. We actually developed a 3D printed electronics pilot line inside the box. And the goal there is what they call point of need. So they want to be able to manufacture where basically within certain miles of the front line, if you want to call it that. So the goal is to really, so you can see, I can't say where in the desert, but there's a place in the desert that we had a system that was being tested. So basically what we support from a digital manufacturing point of view, since it is digital, is to be able to distribute manufacturing. There's a lot of interest, instead of one large big brick and mortar, being able to distribute the manufacturing. So if one area has a hurricane, you can move the files over to another area. And the DoD is very interested in that. They also are very interested in sending these files to other places and to be able to manufacture. So if you're in the field, the Humvee breaks, you go in and you want to fix it. And sometimes you want to fix it just good enough, because the Marines, they tell me, sometimes I just want to get home. So it matters to them. And then their metric is it a 500-mile solution, 100-mile solution, or a 5-mile solution. If it's a 5-mile solution, they carry it. If it's a 100-mile solution, it's probably one of these boxes. And so that's really where we're moving towards. We've done a number of demos in this. Probably the coldest demo we did was at -40. And the reason -40 is interesting is think about the Arctic. Russia likes Arctic, so we have to be there. And be able to fix things. And then of course space. With the bioprinter, we do have a bio team. We have another program we're developing, being able to manufacture blood in the field. So that's an on-demand blood program. And then we have the printer there they've actually printed knee cartilage on the space station with that. And then we have a 3D printed electronics version that's going out next year.
That's kind of going in and out. I don't know if that's better.
Okay, could be me. So anyway, so we're really, from a digital manufacturing point of view, is to be able to, we can design somewhere and build it somewhere else. And that could be a commercial application where you want regional manufacturing, distributed manufacturing. And again, if you're supporting an industry, maybe that would be a point of need. You might place something close to that. So this is just a little bit on the bio side. So this guy here, that's the bio printer. So we were teamed with TechShot, which is now Redwire. We were teamed with them again for the next system. But you can see the astronaut actually using the machine to do print testing up there. But the other part of it is what they call on-demand manufacturing. It's a NASA program, and they want to be able to on-demand make things in space. They want to be able to design it, be able to grind it down, and reprint it and make it something else, because your resources are limited up there, whether it's on this station, on the moon, or in Mars. So a lot of this capability is really moving that direction. And so this part, I'm gonna talk about the workforce development side. I call it filling the gap. And this is kind of an illustration for space. And basically you have legacy knowledge. As us gray hairs retire, you start losing a lot of that. So how do you capture that? And I say insert industry here because it's a problem in a variety of places. In the DoD, you have aircraft systems that are old and they want to still use them 40 years from now. So I know Chris and his team cares about that kind of a thing. But for me, the semiconductor, if you remember, we used to be the prime #1 producer of semiconductors. All that's in Asia, China, and elsewhere. So that's a problem not only from an economic point of view, it's also a problem from a DoD perspective, national security. So really workforce development, and for me, is in the semiconductor side of the thing. And so with the CHIPS program, that's part of so they're trying to build infrastructure for the foundries and then the advanced packaging of electronics, but now you have to, who's gonna work on it? Because all the knowledge went overseas, so we need to redress that. And so the way that happens, I'm the Florida chapter president of IMAPS, and so that services the microelectronics field, and I'll fly through this. So here's the CHIPS information. I think Nancy could put this presentation online, so if you want to see it, because there's a lot of more detailed information on how much money is pumped into this industry. And so workforce development is a big part of it. And so I'll fly through that. DARPA is very much, they've already put out a number of programs, not even listed here, on multiple $million contracts for technology development. There's a lot of local stuff happening, particularly in Kissimmee, Neo City, Bridge, all of that. So I'm very much involved with them. And kind of a Florida packaging ecosystem. we're number 8 in semiconductor manufacturing jobs. Number 5 in the US with 79 semiconductor establishments. That's growing. You got Rogue Valley micro devices that are moving to Palm Bay. They're building a manufacturing plant right now, so this is changing. And we're becoming a big epicenter for advanced packaging. And so the society really supports that whole industry. And there's some information on Bridge. Bridge is a consortium that really leads the efforts to build the ecosystem here. And with IMAPS, we do have online training, so as members, there's things for upskilling in that domain, so you can learn how to do things that we don't know how to do. A number of us still do, but we need to get the information out there is basically the point. And then I have a workshop at Bridge on August 28th on this whole industry. We have technical presentations as far away from Japan that come and present there. And in Boston is our big symposium and so forth. And so this is the IMAP Academy. You can go to the website and you can check that out. Particularly if you're a member, you'll be able to get access to the training and some of the examples of training. And again, we're very focused on future workforce development. I work with a lot of universities, FIT being one, but UCF, University of Florida, USF, FIU, I work a lot with, Florida International University, as well as I do work with high schools, and I'll show some of those examples here. And again, we're focused on workforce development, upskilling in this industry. And so I'm a STEAM guy. We all talk about STEM, but your other half of the brain is the A part, so I think it's very important we need that. As Einstein, he was a musician. He talked about, I would think abstractly when I played music, but then I had to prove it in science, and so it all ties together. Maker Faire is a good community effort that you can put together to bring in, families together. So if you're trying to build an ecosystem, this is one way of doing it from the ground up. We've done 2 here. Nancy's been involved with it. That's when we first met, I think. Back in 2019, we held a big one at Larson Motorsports, and then we did a smaller one recently here. And then I've been involved. I'm an Eagle Scout. I've been involved with the Scouts forever. So our troop did a STEAM day. And it was a 3-day thing. So the first day was pioneering how do you make stuff in the woods. The second day was looking at how do you make stuff today. And the third day was, okay, let's go digital, let's 3D print stuff. They actually 3D printed their pancakes for breakfast on the third day. So, and you can see the pancakes down there. So. I worked with Bayside High. We built a poster that we put electronics on it. So I actually went into the graphics class, not the engineering class, because the engineers know what they want to do. I'm trying to harvest other areas. So they had screen printers and so forth, so they made the poster, we electrified it, and then built Tinker Toy lamps. So they were learning basically electricity 101. Then I took them to an IMAPS conference. They had their own booth and be able to show off their work. And then we did another one where we 3D printed a roulette wheel. It didn't spin, but the electronics we built, they put inside. You push the button in the middle, and the lights basically rotated, and it looked like it was spinning, and it would randomly land somewhere. That student, he had no clue what he wanted to do in life. And so he did the SolidWorks because they were getting SolidWorks certified. And so they put this project together. And then another project here, well, he ended up, when I took him to the booth, the IMAPS thing, he ended up as a junior getting a paid internship at Harris. He didn't know what he wanted to be yet, and he graduated with an engineering degree at FIT. So, here was a cool thing. They 3D printed the housing. They put the phone on it. It would charge it. They added the solar charger and an amplifier to amplify the sound. And then I told him, well, that's all cool, but you're consuming more power than you're generating. And I said, go investigate what Victrola is. Anybody know what a Victrola is? Yeah. It's an old, so it's basically, So they did that. So iteration number 2 was that guy over there. No electronics. And so basically acoustically amplified the sound, no electric power needed, and it's basically a horn. And so various other projects, you know, again, you find their passions. One student wanted to make fishing lures. Another student, he was supposed to get certified in SolidWorks. He just wasn't getting it. Then a part on his motorcycle broke. It was plastic. And he said, can I 3D print this? He said, well, she said, you have to be certified first. He was certified in 2 weeks. That part cost about $200, and he 3D printed it. And again, I took them to an IVAPS conference, and so they got to mingle with the professionals and get exposure there. And then what does the future look like? Well, this is my great granddaughter. For her, it's hugs, burgers, and fries, and muddy puddles, if you know Peppa Pig at home. And the point being is we need to start early. We need to find their passion and then direct it forward. And that's it. Thank you. I can hang around for a little while.
Okay, that would be great.
I have kind of a silly question. Well, maybe it's not silly because it's actually part of technology, but there is going to be clothing that will have electronics and things imprinted into them for, you know, our AI and so forth. Are you dealing with that at all? Is it that plenty with material and so forth?
Yes, if there's a, are you familiar with manufacturing institutes? That was started back in the Obama days. And what they did was start developing manufacturing institutes around the country. They keep adding to them over time. There is one that's solely based on textiles, and they're trying to functionalize threads. So make threads sensors and things of that. So that is being worked on. Stuff that we do is we print onto fabrics, and you look at stretchable conductors instead of copper wires that don't stretch, things that stretch that still carry electricity. And then you have the added challenge is you got to wash the thing, and it's got to survive that, or the soldiers crawling through mud, and they have to survive that. So but yes, there's a whole institute that's focused on that for functionalizing threads and fabrics and so forth.